So let's start. For some of the questions that I've actually forgotten the formula, I'll just be making use of Google to tell me what formulas to use. So the most important thing is just to get things right. Now for this question, number one, check my YouTube channel. I have already solved this particular question. So just go there, check my YouTube channel, IntelliLearn. So you see the solution there. And I think I even shared the link, but not a lot of people were able to get to it. So the current, if you watch the video, the current is 12.5 ampere. So that's the answer. So just check the video for that. Now majority of these diagrams, I won't be looking at them first. So but let's see. The one we can actually start with is question 3. So it says find the number of turns in primary if a transformer has 120 volts and it's producing 12,000 volts in the secondary coil. So the transformer formula is number of turn in primary divided by number of turn in secondary is EMF in primary divided by EMF in secondary. But in terms of current is the opposite. Current in secondary divided by current in primary. Now number of turns in primary divided by number of turns in secondary is 1000. It says it has 1000 turns. Now the EMF in the primary, that's 120 volts, and it produces 12,000. Now the question is not well worded. So it says it has 120 volts. That should be the input or the EMF in the primary. So it should be well stated that the EMF in the primary coil is 120 volts, not that you say it has 120 volts. So you solve this, you cancel out 1000. So we get the number of turns in primary to be 120 divided by 12, and that is 10. So it has 10 turns in the primary. So number 4 says find the distance between two forces, -6 microcoulomb, 8 microcoulomb, and the force between them is 0.015. So we know that the formula to use is the force between two charges, Q1, Q2 divided by R squared. So let's see. So I'll just use my calculator to solve this. So I hope I'll be able to solve it. So the force has been given as what? 0.015. So 0.015 is equal to, so look at that, equal to is alpha, then equal to alpha and this button that has calc on it, so that the equal to sign will just come out. So it's equal to fraction, then k is 9 times 10 to the power of 9, then multiply by the value of the first charge. So the value of the first charge is 6 microcoulomb. So that's 6 exponential minus 6. Then the second charge is 8 microcoulomb. So we have 8 exponential of minus 6. Then divide by r squared. So I don't know that distance. I will say x squared. So I press shift, calc, that's solve for x. Then I press equal to. So that my calculator will just solve. So I have what? 5.37 or 5.36. So the closest option is option C. So that will be the correct answer. You can decide to solve it the normal way too. Just make R subject of the formula. You get the same thing. But why do that when your calculator can just solve the whole equation, help you to do the hard work? So the next question, I don't know the question to this. Okay. So let's see. Okay. So look at this, question 10. The ability of charged bodies to exert force on one another is attributed to the existence of what? Okay, that's the electric field. So electric field is a region where charged bodies exert force on one another. So that's very simple. Just electric field. That's the answer to this. The next one says the angle between the Earth's geographic north-south axis and the magnetic axis is called what? The geographic north-south axis and the magnetic axis. Now, we call it the angle of declination. Yes, angle of declination. So, the angle that, let's assume that this is the geographic axis, north, south. Then the magnetic axis is slightly tilted away from that. I'm not sure if it tilts to the right or left, but this small angle that we have here is the angle of declination. So that's that about that. That's just the definition. So this question again. So as I have said, I've already solved this particular question. So try to check my YouTube channel for this. Okay. This I'm not sure what is going on here because you just wrote the question, did not write what we are asked to do. So let's move to this. So conversion of milliammeter to ammeter. Conversion of milliammeter to ammeter. So that means that a milliammeter is just a galvanometer and you can convert it to an ammeter. So what does that mean? A milliammeter is a galvanometer and it measures very small values of current. It measures small current. That's why you call it milliammeter. So the current is in milliamps, very small. Now, if you want to use it to measure bigger values of current, let's assume that you want it to measure about 5 amps. What do? You connect a resistor with it in parallel. So you connect a resistor with it in parallel. Now that resistor that you have connected with it in parallel, what it does is that when maybe this galvanometer cannot read more than what do I call it? Maybe the galvanometer cannot read more than maybe 5 milliamps, for example. So let's say that's the maximum current it can take, 5 milliamps. So what will happen is that when the 5 ampere current is coming, the galvanometer will take the amount it can take. It will take the 5 milliamps. Then the remaining current goes to the shunt. The remaining current goes to the shunt. So you are supposed to connect them in parallel so that the excess current can follow another path through that other resistor. And the resistor that you are going to use needs to have a very small resistance so that it can take a very large amount of current. So that's the logic. So you connect what? A low resistance in parallel. You connect what? A low resistance in parallel. Okay? The next one says n number of moving charge electron is this, having radius of this, moving around a circular orbit with speed of this. Find the magnetic field of the electron due to motion round the orbit. Find the magnetic field of the electron. How do we do this? What is the magnetic field of the electron? When an electron or when a charge is moving, it generates a magnetic field around itself. And we can actually find the strength of the field. The strength of field by a moving charge. That should be, I don't think I can recall the formula for finding strength of field of a moving charge. We are given the radius. We are given the speed. How do we do it? Strength of field of moving charges. I think we use Bell-Savart law, but I can't remember what the law is. So no problem. Strength of field of moving charge. Or a moving charge. Okay? No. Or am I missing something? Find the magnetic field of the electron. The field of the electron. That should be Bell-Savart, but I can't remember the law. So, I think I saw something now. Bell-Savart law, magnetic field strength at a point due to a moving charge. Exactly. So this is mu naught over 4 pi multiplied by qv sine theta over r squared. So look at that. So mu naught over 4 pi multiplied by qv sine theta over r squared. Mu naught over 4 pi. So mu naught over 4 pi multiplied by qv sine theta divided by r squared. So that r is the radius. R is the radius. We have mu naught. We have q, which is the value of the charge. We have v, which is the speed of the electron. Now, what is theta? So theta should be the angle between the vector. Let's see. Should be the angle between the vector. Look at that. Theta is the angle from the velocity line between the charge and the point of interest. Okay. So that's the value of theta. You draw a line in direction of the velocity. You draw a line to the point of interest. The angle between those two lines is your theta. So that means that let's assume that this is the path of the electron moving around a circular orbit with that speed. So the speed of the electron is this tangential speed. So you draw this. So this line represents your r, right? This line represents your v. So this angle between them is what? 90 degrees. So sine 90 will be 1. So just substitute the other ones into the formula and you have your answer. So mu naught should be 4 pi times 10 to the power minus 7. I've forgotten all these values. Yes, 4 pi times 10 to the power minus 7. So that's the value of mu naught. So just input everything into the formula and you should have your answer. So that means that if I want to do this, I will just say mu naught over 4 pi. So mu naught is 4 pi times 10 to the power minus 7 divided by 2 pi multiplied by what? Another fraction. Q is the charge. 1.6 times 10 to the power minus 19 multiplied by the speed is 5 times 10 to the power minus 6. Then sine 90 is 1 over r squared. Now the radius of the path is 5.3 times 10 to the power minus 11. Syntax error. Okay. So you have 3.01 times 10 to the power minus 21. That's a very small value, actually. Well, That should be the solution to that. So the next one, two charges, Q1, Q2 were separated by 30 centimeter. It was, I can't make out what they asked them to find here. I can't make it out. So it's possible that they ask you to find where the force is going to be equal to zero, or where the resultant electric field will be equal to zero. I'm thinking that should be the case. That should be the case. So the first one is negative, the second one is positive. You have positive, you have negative. So the positive one is 6 microcoulomb, the negative one is minus 3 microcoulomb. The distance between them is 30 centimeter. So where are we going to have the resultant field to be zero? The resultant field would be zero along the line connecting them, but outside of the two charges. So this is the line connecting them. So it will be somewhere around here where the resultant field would be zero. So this distance is r. Now this is another problem. So along the Q1 axis, the question is not well worded. So for them to mention Q1, and this is Q1, so that means that we should find the distance from these 3 microcoulomb where the resultant field will be zero. I'm just making an assumption since I don't know what the question is, but I think that should be the question. So what we just have to do is find the strength of the field at this point due to the 6 microcoulomb. Do the same thing for the negative 3 microcoulomb, then equate the two values, then solve for R. So due to the 6 microcoulomb, let's say E6, that's KQ over R squared. So that's K multiplied by 6 microcoulomb over R squared. Now R will be, the distance will be R plus 0.3 squared. That's the distance from here all the way to this point. So you sum those two distances. While E3 would be what? KQ over R squared also, but his own distance is just R squared. Okay, so equating the two values, you have 6 microcoulomb times K, R plus 0.3 squared equal to 3 microcoulomb times K over R squared. Now, some cancellations will occur. So K cancel out, micro cancel out, 3 goes twice. So we have 2R squared to be equal to R plus 0.3 squared. I'll just use my calculator to solve these two. 2R squared equal to R plus 0.3 squared. So we have 0.724. So the value of R is 0.724 meters, not in centimeters, because if you notice when I wanted to solve, I converted to 30 centimeter to meter. So my R should also be in meter. So 0.724 meters. So that's what we have for that.